Welcome back to the engineering drawing videos. I want to tell you a personal story. Do you know that I've been making engineering drawings since I was in 8th grade? And you can tell by the little gray on the gills here that that's a long time. And I also want to tell you that this has been an exciting business ever since I've been in 8th grade. And here's why. In some classes that I've taken, like history, I love history. I love to read about my ancestors. I love to read about the exciting things that happened in the past. But when I'm done with history class, I have some stuff in my brain, but I don't have a lot to show for it. But with engineering drawings, when I'm done, I have an engineering drawing. I can hang it on the refrigerator. Well, it's a thing that lasts. I've taken an empty piece of paper and created something. And I want to tell you that after 40 years of doing this, that I still get a great feeling of excitement when I take that empty piece of paper and end up with some real thing. So in this lesson, in today's session, we're going to talk about some of the other drawing instruments that we use to create these interesting and useful engineering drawings. Here's a series of points marked, and there's all kinds of situations in engineering design where you might find a bunch of points where you have to connect a smooth curve between them. And I'm going to use the irregular curve to play follow the dots. And the trick in using the irregular curve to play follow the dots is to fool around until you can line up at least 3 dots. But don't draw all 3 of them, only connect 2 of them. And then move around until you can line up the next 3 dots. And don't draw all 3 of those, but only connect 2. There's nothing magic about 3, by the way. If I line up 4 dots, I'm only going to connect 3. And if I line up 5 dots, I'll connect 4. In other words, if you were a mathematician, you'd say line up n dots and connect n minus 1. And you keep doing this until you find just the place that allows you to smoothly connect all of the dots into a nice uniform curve. Now I probably have to find one that goes off in this other direction here. And if you have the full set of curves, you'll be able to always find a bunch of matches, matching connecting dots. Okay, once more here, and I think I get it curved. Whoops, I need just a little more curve than that. I'll turn this over again and find the place where I can line up the last dots. So irregular curves are used, and there are lots of different sizes and shapes, and you have to be patient. And the way you do it is you find a place on the curve that you can match up at least 3 dots, and then you draw 1 less than the number of dots you've matched, and you continue that process until you've played follow the dots using the irregular curve. The next series of drawing instruments I want to demonstrate are called templates. Templates are used mostly when you have repeating patterns. You want to draw the same shape over and over again. For example, suppose that you had to draw interstate highway signs. On this particular template, I have this little hole in here. And by following around in the little hole carefully with my pencil, I can make an interstate highway sign. Or I can make a star, or I can make this particular shaped arrow. This particular template has several different shaped arrows. I can make one like that if I want to make a small arrowhead for dimensioning a drawing, and I might even scribble in the whole gap there. Or I want to make a larger arrow. I can fill this one in. The nice thing about this is no matter how many times I follow around the cutout here, I get exactly the same shape. You notice that this particular template has standard geometric shape. It has circles, small circles of different sizes. It has hexagons. It has triangles, that is equilateral triangles, and it has squares. And so if I need to use any shape that fits this size over and over again, I can use this particular template. Maybe I'm in the house planning business. If I'm in the house planning business, I might want to draw door swings. And you notice there are a whole bunch of door swings here, and they're for different size doors. I can line that up, and I can just fill that in, and with a little bit, I'll use this thing again right there to show the wall thickness that door is filling in. You make door swings. Maybe I want to plan the bathtub. And here I can use this little bathtub template. And if I want to show the drain in that bathtub, I might switch over to this little circle here, draw that to represent the drain in the bathtub. Well, there are templates for almost everything. As a matter of fact, if I show you a page from the Herlihy catalog, you can see that we have templates for architectural work, for furniture, for house furnishing, interior design, plumbing, more architectural. If I go over here and turn the page, you'll see that we have templates for making ellipses, for different kinds of ellipses, isometric ellipses, metric international standard ellipses, and it goes on, small ellipses. We have templates for drawing guidelines for lettering. This would be if you don't need an adjustable one like the Ames lettering guide that we saw in another part of the video. We have dimensioning specialized templates for making different sizes arrowheads. We have the small shapes that you saw before, and we have lots and lots of circle templates for making various size circles, from the very smallest ones to making big circles half at a time. Let me show you an example of using a circle template. Now, whenever you want to accurately construct circles with a template, you need to have the center lines for your circles. And so I've jumped ahead here and created horizontal and a vertical line for the circle. Now, in this example, this particular template has little tiny holes to line up on those center lines so that I get the circle exactly lined with the center lines. And once I have those holes lined up the way I like, I'll just take my uniform lead holder in this case, zoom around and draw a circle. Now, it's much easier to draw small circles with a circle template than it is to use a compass for very small circles. Sometimes on some circle templates, instead of having these little small holes to line up, sometimes they give you little lines that are center lines themselves, and you line those guidelines, those guide center lines up with the center lines you've constructed on your drawing, and then follow around and make whatever size circle you want. You'll find circle templates that have fractional inches. You'll find circle templates that are made for metric. You'll find big ones and small ones. And again, templates, a very handy thing to use whenever you have to repeat a pattern, whether the pattern is round, whether the pattern is something like some kind of house planning symbol, or whether the pattern is little shapes. Templates are very powerful drawing aids. As you've seen, when you want to make standard size circles, you can use a circle template. There are circle templates for lots of different sizes. But there's going to come a time when you want to make circles and you don't have a circle template, or you don't have a circle template that has exactly the size circle you need. So at that time, you're going to need a compass. This is not the kind of compass that points north, unless you point it north. This is the kind of compass used to make circles. Did you know that 2,000 years ago, more than 2,000 years ago, the ancient Greeks were using compasses to make circles and arcs? An arc is a part of a circle. As a matter of fact, Archimedes, do you think they call them arcs because Archimedes made them? This ancient Greek named Archimedes was constructing things using a compass, and he was doing all kinds of mathematical experimenting using arcs and straight lines. Some compasses have a very large smooth thread, and they're called speedboat compasses. You need to find out if you have this before you try this trick. With a speedboat compass, all I have to do is grab this, and very quickly I can speedily move from a small adjustment to a large adjustment. Once I've adjusted the compass to the size that I want, use the point of the compass to mark the center of my arc or circle, and use the lead that's in the compass to scribe the arc or circle. Now, I want to show you something else. Not all compass points are created equal. There are two different types of points that you might find on the pointed end, not the pencil end, but the pointed end of the compass. I just want to tell you briefly about those 2 points and how they're different. The one point is a little hard to see on the video, I know, but one point has very fine point and it comes to a shoulder. just like your head has shoulders, this point comes to a place that juts out. The other side is just a straight conical point. And this is the point that you would use in ordinary use, like in a math class compass or grade school compass or whatever. Or if you did not have a proper drawing surface underneath, you would use this point. We have on this drawing table, we have something called a Borco board cover, not just a wooden surface, but a special resilient thing designed so that the compass point can stick in. And in that kind of drawing situation, I would not use the conical point compass, because if I'm making a lot of concentric circles, that is lots of circles that have the same center, if I kept pushing this point in harder and harder, it would keep making a bigger and bigger hole as this taper worked its way in. On the other hand, the point with the shoulder, I can only push it so far and it will stop and it will be much more precise. So that's the point I'm going to use in the compass on a proper drawing surface. There are a couple of possibilities of the source of this lead. One is we could get a package of lead, but we could break a small length of it and sharpen that. But they also sell special compass leads. This happens to be a package of a gross, one gross. A quiz question for you. How many are a gross? How many things in a gross? A dozen, 12 times 12, 144 leads in a gross of compass leads. And if you were using a compass a lot, or if you were buying for a whole department, you might buy a gross of leads. In any case, you'll have to sharpen it. And the point on the compass is not a conical point like it is on a drawing pencil, but it's sharpened to this wedge shape. And the way we do that is we use a little sandpaper pad. And then we hold the lead a certain way. First of all, we want to hold it at an angle of about 60 degrees to the vertical. And then we want to maintain, not twisting sideways, we want to maintain this perpendicular to the sandpaper pad. And then we scrub that back and forth until we get this nice wedge shape point. Now I've got all that garbage, all that stuff. I shouldn't do this over the drawing table. I should do this over the wastebasket. I have one off to the side. I wanted to show you this, so I did it right under the camera, but I have a wastebasket right over here. And I can shake all that lead. I also have a little bit of lead clinging, a few lead particles clinging to that point now that I've sharpened it. So I can use the same ring or any piece of old styrofoam or an art gum eraser, poke that in and out and pick up those particles of lead, because I don't want them to fall on my drawing surface and actually get rubbed around and cause a gray ghosty smudge. Now that I've got the compass all sharpened up, I can draw some circles. How big is a circle going to be? Well, circles are measured by diameter, but when you're using a compass, you have to adjust the compass to the radius of the circle. So you take a scale and you put the point of the compass at the 0, and I'm over here on this little knob now. I'm going to adjust with that adjustment knob until I get this point exactly at the radius size, which is half of the diameter that I want to make the circle. Once I've adjusted that, then I'll very carefully put the point right in the crosshairs, right in the crossing center lines, and then I can swing this around and draw either a full circle or an arc. And I'll try to be very careful so that this arc will be nice and uniform. I don't want to do too much of, whoops, got my hand in the camera. I don't want to tilt it too much this way. I don't want to tilt it too much this way. And I certainly don't want to change the tilt from one side or the other, or I'll get kind of a tapered line or a changing width line as it goes around the circle. Now, if you're doing an awful lot of compass work, you might want to invest in an implement to use as a trick to make nice uniform width lines with your compass. Let me show you an adapter that we can use for that. Here's a little adapter that our friends at Hurley sell. And you notice that it has this little bar with a groove on it, and then it has this little slot. There are some compasses that allow you to unscrew this thing and take out the part that holds the lead. And you notice that that has a little groove with a slot. And that's designed so that I can put this adapter in there in place of the lead. I'll just tighten this up. And then I can actually put my uniform lead holder, my uniform lead pencil, in here, adjust it just the way I want, tighten it up, and then when I draw circles, I can draw them with this nice, in this case, 0.7 millimeter, or in some cases 0.3 millimeter thickness lead. And if I'm doing a lot of circles, it's worth investing in one of these because I'll have a much better quality line. If I'm not doing very many, if I'm not a professional, that is, I may not want to bother with this. I can just use the standard lead holder for that. But I just wanted to show you that trick in case you really get serious about this business and start producing lots of circles with a compass. You might recall that when we wanted to make a lot of very small circles, we used the circle template. If we wanted to make unusual size or larger circles, we used a compass. You might wonder, how big a circle can we make with this compass? Remember, this one was a speed bow. Well, if I crank this out to the max and I check it out on the scale, I find out that this will make a circle that has a radius of 7 3/4 inches. But what if I want to make a circle that's even bigger than that? What do I do? Well, we have another instrument that allows us to make very large circles. And this instrument is called a beam compass. This particular compass, because I can remove this lead holder, can act as a beam compass. And what happens is I install this extra extender called a beam, like in a beam in a house. And out here at the end of the extender, I install my pencil. And this little screw here allows me to adjust the position that that pencil is on the beam. So you can see that now we've extended our radius out to a very large radius circle. But if you're in the business of maybe drawing large scale drawings like parts of airplanes or boats and you need something even bigger than this, you'll find a compass that only has beams. You'll find a long beam, and instead of the dial adjustment, the point will attach right on the beam and the pencil will attach just like this. So there are lots of ways to make circles with these drawing instruments. And a beam extender or a beam compass is one way to make larger and larger diameter circles. Here I have another example from our friends at Hurley of a drawing instrument set, and this particular instrument set includes two different compasses. The small compass, if we're doing a lot of small circles, the larger compass, as you saw before, and this one can be adjusted. We can remove the lead part and we can replace it with one of those adapters or a beam adapter. And it has this little container. It's hard to see black on blue, but a little container that contains extra points for the compass and extra leads. And then it has this little device here called a divider. And let me show you how the divider is used. By the way, if you're going to be serious in this business, if you're going to make this your career, a good instrument set is something worth having. And if you get a good instrument set, it will last a lifetime. As a matter of fact, I still have, and it's still very useful, the instrument I purchased as a student at Penn State in 1959. You know how old I am now. Let me show you how we use this dividers. It can be used for two things, actually. It can be used to divide, and it can be used to transfer distances. Let me do the first part. Let's divide this little line that I've drawn. Let's get a little closer. You see this line that I've constructed here? Suppose that this is part of an engineering design, and I needed to divide this line into several equal spaces. There are several different construction techniques we can use to actually divide lines into equal spaces. And chances are that we're going to run into lines where we don't want to do it by measuring the line and then doing some math. Might be faster to use the dividers and the so-called trial and error method. I want to divide this line into 3 equal spaces. So here's what I do. I make a guess. I put this dividers on here and I say, I think that's about 1/3 of that line. And so let's check. There's 1 division. I just put the point in, rotate it. 2 divisions, 3 divisions. Whoops, I guessed too big. I don't know if you can see, but I've got a little extra there. So what I'm going to do, doesn't take long, takes less time than it does to to do this than it does to explain it to you. I just made that a smidgen smaller. I think I made it about a third smaller. Let's see if my second guess is any better. 1 division, 2 divisions, right on. I'm within a pencil thickness of knowing exactly 1/3 of that line. Now I can go back, if this is my real job, and I can make marks. And I now have that line divided into equal parts. I could have just as well divided it into any number of equal parts using the divider. So that's one application for the divider. Another application is to transfer distances. Suppose I had some other line on my drawing. Let me just put one in here. And I needed a distance on this line that was exactly 2/3 of the distance on the original line. So let me set this here at the second mark, 2/3, and now I can transfer this distance over to this other line. Now you're not going to be able to see this on the video. You're not going to see what I'm doing, but I'm giving a little bit of pressure, and I made a little tiny pinprick hole in the paper. And that little pinprick hole marks the exact 2/3 distance that I wanted to transfer, and now I can just extend this line to that point. I'm even going to make a point there to show me that that's where it was. So the illustration was that I wanted to transfer a particular distance to some other line. In this case, I wanted to transfer 2/3 of the length of this line. I don't know what it is, I didn't measure it, but I know exactly 2/3 because I used my dividers to figure it out. So I can set that on the 2/3 distance, and I can transfer that distance anyplace else. Now, if you get into an advanced class called descriptive geometry, there'll be lots of applications for transferring distances from one view to another view, and the dividers is a very handy tool to use for that. So dividers, double duty. Use it to divide lines, use it to transfer distances. The next type of drawing instrument to be discussed are called scales. First kind of scale I want to talk about is this mechanical scale. It's used mostly for mechanical drawing. I want to talk about the fractional divisions here. The major divisions that are numbered are in inches in this particular scale, and it's subdivided into a number of parts. Now, on nearly every good scale that you run across, you will see a number here at the end of the scale indicating the number of small divisions that each major unit is divided into. In this case, 1 inch has been divided into 16 parts. You will also notice that there are major and minor divisions here that are indicated by different lengths of lines. If we take 1 inch and divide it exactly in half, we'll have 1/2 of an inch. Let's look at an example of using the 16th scale to measure 2.5 inches. Notice we go 1, 2 major divisions, and 1/2 division. And you'll see here that we've measured 2.5 inches. Let's look at some of the smaller divisions. For example, these next longer lines, if you count them, there'll be 4 of them, or each one of them will be 1/4 of an inch. If we want to measure something longer than an inch, but comes out a multiple of 1/4 inches or 1/4 inches, for example here, you can see that we've gone 1, 2, and 1, 2, 3/4 of an inch. So even though we're using the 16th scale, we're looking at not half, but 1/4, and in this case 3/4 past 2 inches, or 2 3/4. Let's look at another one. The next smaller division is 1/8 of an inch. If we look at those divisions, 1, 2, 3, 4, 5, 6, 7, 8, we can see we can find 8 equal parts, 1/8 inch parts. An example of that would be to measure 2 5/8. Here's 2, and here's 1, 2, 3, 4, 5/8, 2 5/8 inches. And then we get to the smallest division on this scale, which is the 1/16 inch division, and there are 16 of those in each inch. And we can use that to measure something like 2 7/16 inches. Here's 2, and there are 2 16ths in every 8, so there's 2, 4, 6, and one more is 7 16ths. So you can use this for measuring 2 7/16 inches But keep in mind, when you're looking at a basic inch scale, this number over here will give you the clue to the smallest possible division you can measure with it. Now, there will be some people who will take this scale and they'll tell you that they measured something that was 3 2/32 inch long, but they were guessing. They could guess to the nearest 16th, but anything smaller than that is a guess. This is only accurate to nearest 1/16 of an inch. Let me show you a couple of different scales. You will recall that scales are used to measure things. We don't use a scale as a straight edge. You would not use this nice precision divided scale as a drawing tool and put it down and, some people would just wrap your knuckles with a scale or with a big stick if they saw you doing that. These are for measuring. And this particular scale, which happens to be a Hurley Model P 235 MT, which doesn't mean anything, but this particular one is interesting because, first of all, it's triangular and has multitudes of different scales on it, but it's also a combination scale. So it allows me to show you a number of different kinds of measuring scales. Here we have the number 16, which you will recall means that this unit is divided into 16 parts. So this scale is inches divided into 1/16 of an inch. If I turn the scale slightly, you'll see on another side of the scale a 1 to 100 metric scale. This means we've taken and divided a meter into 100 parts, which means that each of these smallest divisions on this scale are 1 millimeter. Here is 1 centimeter, and if you're into the metric system, you know that 1 centimeter is the same as 10 millimeters. And if we count these, 10 of them. So there we have a metric scale, and that 1 to 100 tells us how much the meter is subdivided into. If I turn it around once more, here I have another inch scale, but it's divided into 50 parts. Each one of these smallest divisions is 1/50th of an inch. You do a little arithmetic. Let's see, 1 inch divided 50 times. That means the smallest division on here is 0.02 inches long. 0.02 is the same as what a machinist would call 21 thousandths of an inch. As a matter of fact, math teachers and machinists don't talk fractions the same or decimal fractions the same way. Whereas a math teacher might say 2/10 of an inch, a machinist would never say that. If we look at this now, though, you notice that there are numbers here, 2, 4, 6, 8, 10. This is 0.1 or 100 thousandths. This is 0.1, 0.2, 0.3, 0.91 inch. So here we have a 50th scale. The smallest part means, the 50 means the smallest division is 1/50th of an inch, or 0.02 inches. Well, we started there. Let's turn it end for end and go on the other side. Here we have a half size scale. Now you have to be careful on this. You have to know whether you have a half size mechanical designer scale or a half size architectural designer scale. This is an architect scale. And you'll notice here that this scale is divided into lots of parts, some of which are numbered, 3, 6, 9. If you count these, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why would they divide a scale into 12 parts instead of 16 parts? Well, architects in the United States work in feet and inches, and each foot is divided into 12 inches. So if you wanted to make an architectural plan, a drawing of a house, where you had 1 inch representing 1 foot, you would have to have 12 parts. Now, on this architect scale, if I go to the other end, you will see a half scale architect scale. This is 1/2 inch divided again, though, into 12 equal parts. What if I wanted to measure 2 feet 3 inches? Well, here's the number 2. Here's 2 feet. This is 1 foot. 10 is coming the other way. Plus from the 0 over, it would be 2 feet 0 inches, 2 feet 3, 6, 9. So this is divided into 12 parts for dividing feet and inches. That's the 1/2 inch equals a foot scale on an architect scale. And somewhere on the scale, it will tell you whether it's an architect scale or not. Now back over on this other half size scale, is that a ½ inch per foot, or is it half scale for mechanical drawings? The way I tell is I count the divisions. There's 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8 are 16. I know that this is a half size 16th scale. What does that mean? That means if I was making a drawing that was half as big as real life, I would use the half size scale, and I would use these big divisions out here, 1, 2, 3, 4, for my major inches, and I would use the smaller divisions for my fractions of an inch. So if I wanted to measure 2 1/2 inches, I wouldn't have to do any math. I'd measure 2 inches to the 0 and a ½ inch more. Or if I wanted to measure 3 1/4 inches, I'd measure 3 to the 0 and 1/4 more. So this is a half size mechanical scale as opposed to an architect scale. Down on the other end, they have a quarter size. And here they go the other way. 2, 4, 6, 8. Here's 6 1/2 inches, 1/4 size. Let's see what else is on this combination scale. A 1/8 size scale, and on the other end of that, a quarter scale again. There's one other scale on this combination scale that's labeled 1 to 50, and if you look close, you'll notice that that's not 1 inch. If I compare it to 1 inch on the regular scale, it's smaller than 1 inch. But you also may recall that we had the metric 1 to 100 scale. Well, this is a metric 1 to 50 scale. So if you wanted to do a metric reduced size, that is 50 parts per meter instead of 100 parts per meter, you'd use this 1 to 50 metric scale. So the combination scale has lots of choices. Again, most of the time, you will find that the key to reading the scale is to see how many divisions. First of all, see what the major divisions are, see whether they're inches or meters or fractions of meters, and then to look at this number to see how many divisions they've divided that unit into, 16 or 50. These scales, again, if you invest in a good one, can last a lifetime. I'm going to show you an old scale that I bought when I was working as a draftsman in 1961 at Bell Telephone Laboratories. This is a 32nd scale. Pretty hard to see these divisions on the video, but now we have 1 inch divided into 32 parts. You don't usually use that for regular beginning classwork, but when you're working on mechanical designs for spacecraft like the Telstar spacecraft satellite system that we were working on back in the 60s, you might need a precision mechanical scale divided into 30 seconds. For general use, sometimes you can use a scale like this one, a simple combination. Inches on this side, and if you count them, you'll find they're 16, and centimeters, 10 millimeters per centimeter on the other side. This one is kind of interesting. Although it's a relatively inexpensive scale, it gives you lots of extra information. You have fraction to decimal equivalents, and you have metric dimension equivalents of each of these fractional inches and decimal inches on the scale. So very handy things, these scales, and there are just lots of them. But remember, if you find somebody calling this thing a ruler, if you say, hey, got a ruler? Don't hand them one of these. This is not a ruler. A ruler is simply a straight edge for ruling lines. The edge of my T-square is a ruler, or the ruler is a king of a country, but this is a scale for measuring precisely. Well, this completes our brief tour of some of the basic drawing instruments. We started out by playing follow the dot, by connecting a series of dots using a set of irregular curves, where the trick is, you might recall, to line up n dots, but to only draw n-1, and then we'll get a much smoother curve between the dots. Then we took a look at some of the many, many templates that are available. We took only a quick look. There are lots of these templates, and we saw how we can use templates for furniture, for making highway signs, or for making circles. And then we explored more arcs and circles through the use of a compass. And we saw that we could use an adapter on the compass so that we didn't have to use the wedge-shaped point. We could use a regular uniform lead holder. We also saw how we could use a beam extender or a beam compass to draw very large circles. Then we talked about scales. Remember, I'm the ruler here. If you want to measure something, you use a scale, not a ruler. Rulers are actually for ruling lines. In the old days, you go to Mount Vernon and visit George Washington's residence, you will see that he actually used a pen called a ruling pen when he was making drawings as a surveyor and an engineer. And those ruling pens were even used in my younger days. I had to learn how to use a ruling pen. But they were ruling straight lines. They were not measuring things. We use scales for measuring lengths of lines or lengths of other things. So now that you have some basic ideas of how to use the fundamental drawing instruments, you'll be ready to start drawing. In the next videotape in this series, we're going to get some serious use out of these drawing instruments, and we're going to start learning how to make multi-view engineering drawings.